Okay, in this video we're going to be having a look at question 7 of the WJC additional maths paper from June 2014. So we have the coordinates of the points D and E are -1, 13 and 5, 5 respectively. And we want to calculate the length of the line DE. So whenever we have a coordinate geometry question, I've always find it very, very useful to draw a quick diagram. So I've made a diagram here. It just gives us a better idea about what's happening with the question. So there's no scale involved in this. It's just a quick sketch. And we need to calculate the length of the line DE. So if I go from D to E, it'll be working out that length. Now this is essentially Pythagoras. We could create a right angle triangle there. And this is the hypotenuse, and the other two sides are A and B. So the formula I'm going to use stems from Pythagoras, but I'm going to use a coordinate geometry version of it, which is that the length DE is equal to the square root of... Okay, so I'm going to try and work out this distance here. So this distance is the difference between the two x's, so 5 take away -1. So I'm going to treat that as x2 minus x1 all squared. So I'm talking about x2 and x1 as different coordinates or different x ordinates. Plus, so that's a squared plus b squared. B in this case is going to be the height. So it's the difference between those two. The difference is, again, is the subtraction. So it's y2 minus y1 all squared. So if I make my substitutions, this becomes, so if I take this as my x2, y2, and this is my x1, y1, so I get x2 minus x1 is going to be 5. Take away -1, so you can just write that as +1 if you wanted to, all squared, plus, okay, so the y's are going to be y2, 5, take away 13. So 5 take away 13, all squared. So you can do this on your calculator if you like. So this is the square root of 5 plus 1, all squared, plus 5 minus 13, all squared, which is root 100, which is 10. So this is 10. I don't need to put units on because there's no units in the question. Okay, part B. Find the gradients of the straight line that passes through the points D and E. This is where the diagram helps us out because we can see from the diagram that we have a negative gradient. Okay, so our answer here should be negative. So in order to find the gradient of the line that passes through DE, D and E, well, that's going to be the same as the gradient of the line segment that I've just drawn, is the difference in the y values over the difference in the x values. So the difference in the y values is the height. The difference in the x values is the width. So it's height over width, or rise over run, however you normally would say it. So this is just the algebraic way of writing it. So my y2 minus y1, if we stick with the same x2 and y2 and x1 and y1 from before, I'll have 5 minus 13 over 5 take away -1, so 5 plus 1. And that will give me -8 over 6, which is -4/3. Okay, so you're always worth checking it on the calculator just in case you make a mistake. So, yep, -4/3. And that makes sense to us that it's negative because you can see that this line is sloping downwards. Okay, part C. Find the equation of the straight line. So we're looking for a straight line that passes through the points D and E. So it goes through D and E. So it is the equation of this line that we've drawn, but not just the segment, but the whole line. And we want it in the form AX plus by plus c, where a, b, and c are whole numbers. Okay, so If I want to find the equation of a straight line, I'm going to use this formula, y minus y1 equals m bracket x minus x1, where m is the gradient of the line that I'm looking at. Well, we already have that from up above. And we have our x1, y1, our coordinates of a point that lies on a line. Well, we have two possible choices. You can either use D or you can use E. It doesn't matter which one that you use. So I'm going to use E because they're both positive numbers, 5 and 5. So I'll end up with y minus 5 equals negative 4/3 bracket x minus 5. So we want it to form in a particular format, so everything has to be a whole number. So the first thing I'm going to do is get rid of that fraction by multiplying by 3. So that will give me 3y minus 15 equals, and if I multiply by 3, then it's gone from the right-hand side. All we have to do is to expand now by negative 4. So I get negative 4x plus 20. Okay, and the format we want it in is x's and y's on one side, constant on the other. So I'm going to add 4x to both sides, and that will give me 4x plus 3y equals, so I don't want that negative 15 on the left, so I'm going to add that to both sides. That'll leave me with 20, add 15, which is 35 on the right-hand side. And that's my final answer.